In this video, we will try to understand what a promise is, how it works, different ways we can use the promise, and more importantly, why we need promise in the first place. So let's see this with an example, a real world example. In synchronous programming, tasks are executed one after another in a sequential order. Each task must complete before the next one starts. So this is the traditional way of writing JavaScript code, where operations block the execution until they are finished. Let's see this with an example of running a restaurant in a synchronous way. Here we see that we have only one guy running this whole restaurant. Let's call this guy main thread. Okay, so he's the only thread. He is the only thread in the restaurant. It means that he, the main thread, will take the order, prepare the food, and deliver the food back to the customer. And he cannot take the next order until the first order is complete because he is the only guy doing everything. Okay, and he is doing everything in a sequential manner. There is a better way of doing the same thing, and that is asynchronous way. So this is the asynchronous way of running the same restaurant. Here the restaurant has hired one more person. Okay, he's the chef. He will do the actual cooking. And the main thread is now free just to take the order, and he is going to pass that order back to the chef. It is the chef's responsibility to prepare the food in the background, and when the food is ready, just deliver the food back to the customer. So this way the main thread is free to take new request or new order, okay, from the next customer. Asynchronous operations do not block the execution of the main thread. They execute in the background here and notify the main thread when they are completed using a callback function. So this example is a very simple synchronous work. So it has three functions: step 1, step 2, and step 3. Step 1 prints 1, step 2 prints 2, step 3 prints 3. And we are executing these functions in this particular order. So obviously, if we run this, it will print 1, 2, and 3. So let's run this. Now let's introduce some asynchronous work, okay, in step 2, for example. So let's comment this out. And let's introduce an asynchronous work here. So set timeout. Here is the callback. Okay, and let's give maybe 5 seconds. Okay. Okay, so what we are doing here is this set timeout will execute asynchronously. So it will wait for 5 seconds and then print 2. Okay, so let's save this and see the output. Okay, so it printed 1, 3, and it will wait for 5 seconds and then it will print 2. Okay, so 1, 3, 2. Everything is good except for the sequence. Now our sequence got messed up. I wanted to print 1, 2, 3. So how can we fix that? One simple way to fix this problem is to call step 3 after it prints 2. Something like this. So we can call step 3 here. Okay, and then we can comment this out. Let's save this and see the output. So it is 1, it will wait for 5 seconds and then print 2, and immediately after that it will execute a step 3 function which will print 3. Okay, so this makes sense. But now by doing this, we introduced some tight coupling here. So step 3 is now hard-coded inside this function. So let's break this dependency. So what we can do here, we can say that, okay, this is rather than step 3, let's call it CB, and we pass CB here. Okay, so now what we are doing, we are just giving it a function to run, and it will actually run the function here. So now we need to pass the function pointer when calling step 2. Okay, so from here we want to call a step 3 function. Okay, let's save this and see the output. So the output will not change. It will be exactly like how it was before. So what we are doing here is like we are just passing the reference of a step 3. We are not calling a step 3 here. Remember, okay, the calling is actually happening here, okay, at line number 9. We are just passing a step 3 reference. So the CV is nothing but a step 3 reference, and then here the CV gets called, the step 3 gets called. Okay, so far so good. Now imagine a situation wherein once this asynchronous task gets completed, we need to fire another asynchronous task. So let's do something similar. Set timeout, and let's give it a callback. And this is the body of the callback. And this time, let's suppose it will finish in 3 seconds. Okay. And now inside this inner callback, we will call this callback. Okay. Let's save this and see how it runs. So first it will print 1. After 5 seconds, it will print 2. And then after 3 seconds, it will print 3. But now the problem here is that now our code is getting complicated. Okay. There is callback inside callback inside callback. So this is called callback hell. Okay, it's basically a situation where you have a lot of nested callbacks. So see, here we have a callback, and this callback is inside this callback, and this whole thing is inside this callback. So it is very confusing. Now let's see how promise can help us simplify this particular code. So what is a promise? So let's see this with an example. Suppose you need to go somewhere, and for that you want to book an Uber. So you called the driver. The driver told you that he will come to your house in maybe 30 minutes. So in this process, what happened is a driver has created a promise. Okay, driver has promised you that he will come in 30 minutes to your house. Now he may come or he may cancel the ride. So what's happening here is when the driver made you a promise that okay, he will come in 30 minutes, so a promise got created, and the state of the promise is currently pending. So the promise is currently in the pending state. If the driver shows up and he comes in 30 minutes, the state of that promise will become fulfilled or resolved. But if the driver cancels the ride, the promise will be in the rejected state. So a promise has three states: pending, fulfilled, and rejected. So there are three states. So the pending state is the initial state when the promise is actually created and it has not yet been fulfilled or rejected. So that's the first state of any promise. When it gets created, it is in the pending state. Now, the fulfilled state or resolved state is when the asynchronous operation completes successfully and the promise value is available. Okay. But the rejected is the state when the asynchronous operation encounters an error. So these are the three states a promise can be in. Let's see how we can create a promise. So we create a promise like we create a new object. So new promise, simple. And now this promise will take two parameters. Okay, they are basically the two callbacks. So now the promise needs a callback function. So we need to provide a function here. Okay, this is the callback function. Now it takes two callback functions as the parameter, maybe like for example a comma b. Okay, now a is the resolved callback function, the function that will be called when the promise is resolved, and b is the function that will be called when the promise gets rejected. So rather than calling it a and b, let's call this meaningfully resolve and reject. So we can call it resolve, and second is reject. So remember, these are basically the callback functions. Okay. So here, this is the body of the promise. Okay. When we create the promise, this body gets executed. So let's put a logic here. Okay. So let's, for example, let's create a variable and we check if the variable's value is, for example, 2, then call the resolve, otherwise call the reject. So let's create a variable called sum, 1 plus 1. We can say if sum equal to 2, then we just call this callback function. So remember, this is a function. Okay, you need to call this function. So here is how we call this function. Okay, with a parenthesis. Else, we need to call reject callback function. So we say reject and call this function. That's it. So now this is how we create a new promise. Let's assign it to a variable. So we can say const p equal to this. Okay, so now we created a promise and assigned it to p. Most of the times, I would say 95% of the time, you don't have to create a promise. Okay, so some library will return a promise. Like for example, if we have to call an API, it will return, most probably it will return a promise, or maybe in Angular, for example, RxJS, it will return you an object variable that you can convert to promise and then use all the promise features. So here is the promise. Now we need to say that, okay, if the promise is successful or if the promise is resolved, okay, same thing, successful, resolved, or fulfilled. Okay, the meaning is the same. So if the promise is in the resolved status, I want to attach a callback function here. So we can say something. If the promise is successful, give me the data here. So there is a method called then that the promise gives us to attach our handler method if the promise is successful, if the status of the promise is resolved. And here we need to attach our callback function. So it will call this function here, this function, if promise gets resolved. But if the promise is rejected, it will not go to then. We have a separate method. Promise provides us with a separate method called catch to catch any rejection. So we can say something like catch here. And here also we can pass some callback function that will be executed in case the promise gets rejected. Here in this case, we know 1 plus 1 equal to 2. So sum will be equal to 2. And this condition will be satisfied. So the promise will be resolved because we are calling the resolve function inside the promise body. So it will come to then because it is successful. So now we can do whatever we want here. We can say that, okay, successful, for example. So we can console.log success, for example. Okay. But if we make it, for example, 10, then sum will be equal to 11. This condition will not pass, and then the control will come to reject. So reject will be called. So when we consume this promise, the control will come to catch, not then. So here we can say console.log failed, for example. Okay. Promise gives us a third method called finally that will get executed irrespective of the fact that the promise got resolved or rejected. So if the promise gets resolved, it will go to then, it will execute this, and finally, and let's print here done, for example. Okay, done. Let's save this and run and see what happens here. Okay, so this is console, oh sorry, console.log. Okay, so now this promise failed. So the promise is in the rejected state. So then will not be called. So catch, it will go to catch, it will print this, and then it will call finally. Now let's pass this promise. Now let's resolve this promise. So control S, now success and done. See this finally block, this callback methods get executed irrespective of the success or failure. It will always be executed. Okay, here you can put some kind of like cleanup code or something, whatever you want to do. Okay, now let's go back to the same callback hell function and let's try to convert this to promise. So let me comment this out. I got a copy, comment, and then paste here. Okay. So what we can do here, let's not pass callback function here. And let's do here resolve. Let's put this whole thing inside the body of the promise. Something like if we return new promise, and here we need to say resolve and reject, and here is the body of the promise, right? So let's move everything inside the body of the promise. Okay, so what we are doing now is we are just calling the resolve. It means that once control will come here, it is going to resolve the promise. So this is step 2, what it is returning? It is returning promise. So we can comment this out, and what we can do rather is we can just call step 2. And so let's attach a then method here. Okay, that will be called when this promise got resolved. It means that the control came here. So that is the point when we will call step 3. Okay, so let's call step 3, for example, here. I saved this and the sequence should be 1, 2, 3. So see what happens. See 1, 2, and 3. So what advantage we got is that now we don't need to pass a callback to the function. Rather, we can attach then to listen to the resolved status. This is to make sure that the sequence in which our control flows is correct. So step 3 will always be executed after step 2. One good thing about promise is that it can be chained. But then also returns a promise. So if I say step 2, for example, and say then dot then, this then also returns a promise. So what will happen? This became a new promise. And because this is a promise, we can attach a new then to it. And now this will also return a promise. So this whole thing became a promise. So we can attach another then to it. So this is called promise chaining. And then finally we can attach a catch here. Okay, so this is how we chain promise together. Let's suppose this is our promise, first name. So this promise returns Navendu, okay, in the resolved status. Now we need to attach a then callback. So now here, then. Now this promise is returning a value, okay, a string. So we can get, for example, this value in this variable. And let's, for example, just console.log this first name, f name. So here in this example, we are going to see what all things we can do inside a then function. And remember, then function itself returns a promise. So it means that we can attach one more then function here and then capture the data that this then function is returning. So right now it is not returning anything. So here we will get undefined. So let's, for example, we get data here. Let's console.log this as well. Data. Now let's save this. Okay, so now we got Navendu because this promise is returning Navendu. It is resolved, and fname will contain Navendu, and we are just printing this here. Okay, and now because this promise is not returning anything, data here in the next then will be undefined. So it is getting printed undefined. The other thing is that we can just return something. So let's see, for example, we are returning fname again. Whatever we are getting from here, we are just returning. So what it will do, it will pass this first name to the next then data. So now our data will become fname. So let's save it and see the output. So now here is Navendu. Okay, because we have commented this out, it's not printing the first. Okay, so now Navendu. So this Navendu is from line number 7. It's here. And this Navendu is from line number 10. It is this one. Okay, let's put it in a curly bracket just to make it more clear. Okay, perfect. Now we can also return a promise here. Rather than returning a synchronous value, we can return a promise here. Something like this. Return new promise, again resolve, reject a callback function, and then let's resolve this. Okay, resolve, and just pass fname. So what will happen here? Now data will receive fname because this is another promise. Let's save this, run it. No change in the output. What if we return a rejected promise? What will happen? If we say reject fname, then obviously because this promise is in the rejected state, it will not go to then, because then is only for resolved promises. So we need to add a catch block here, something like this. And maybe we can get the error here, and again console.log, and let's print error, save. Okay, so now it is rejected, but this time this is getting printed at line number 17, which is this one. So it is going to the catch block. So maybe we can, rather than sending the actual first name, we can say something like error occurred. Okay, something like this. So now we will see error occurred here. So let's comment this out and just add Kumar after first name of Navendu. So we can say something like return fname, okay, Kumar. Okay. Now this then is returning Navendu Kumar. So this data at line number 14 will be equal to Navendu Kumar, and we are going to print it here. Let's save this and run it. So we got Navendu Kumar. Or we can even throw some exception here. For example, we can throw error, and error occurred, for example. Okay, this is the reason that we are giving. Let's save this. Okay, so first it printed Navendu. Now here we threw the exception. So the promise was now rejected. So it will not go to this then, and it will come to catch with the error that is getting thrown from here, and we are just printing the error. See here, it is coming at line number 19. Line number 19 is in the catch block. So these are a couple of things we can do in the then block. Okay, remember, if we do not return anything from the then block, the next then block will get undefined, okay, as the parameter. There is another scenario where there are multiple independent promises. Okay, multiple independent promises that needs to be executed simultaneously. Like, for example, let me delete this. Okay, consider three web APIs. Okay, they are not dependent on each other, but we need to call them simultaneously, because if we call them one after another, it's going to take more time. And because they are independent of each other, we can call them all at the same time. And for that, we use promise.all. So we can use promise.all, and then here we just pass promise1, comma, promise2. This is an array, promise3. So this will give us a new promise. So for example, const promise. Okay, so now we got a new promise. The data that we will receive here will be an array. So this data will be an array. This data will be an array of the result of these three promises in that order. So the data will be something like this, for example. Okay, result 1, result 2, result 3. So now this result R1 is the result of P1, R2 is the result of P2, and R3 is the result of P3. Okay, so the data will be something like this. If we need to extract the result of the first promise, we need to work with this particular array. So we can say data index 0, this will give us R1. Data 1 will give us R2. And data 2 will give us R3. So let's see with an example. So here I am calling the actual web API. This get user function is returning a promise. Okay. And here we just pass an ID, and this API will return the user of that particular ID. So we are passing get user one. It will return the user with ID one, and we are just collecting it in user one promise, user two promise for ID number two, user three promise for ID number three. So now we got three promises. So one way to get the data from all of them is like this. First call this API. When this finishes, then call the second API. When the second finishes, then call the third API, and then finally collect the data for all. This way, your APIs will run in sequence, one after another. We don't want that because these three APIs are independent. Second API result does not depend on the result of the first API, and third does not depend on second. So these three are totally independent. So in this scenario, we can use promise.all. Okay, let me comment this out. Okay, so here we can use promise.all, pass this array of promises here, promise 1, 2, 3, and then when all of them are successful, we will get an array of results. So the first element of this array will be the result of first promise, second element of this array will be the result of the second promise, and similarly, third result of this particular array, users array, will be the result of the third promise, and we can just print those data here. This is how we use promise.all to call multiple APIs that are independent of each other concurrently. Now let's see what is async-await. So async-await is just a way to work with promises. Okay, this is just a sugarcoat of her promises. Makes our code a little bit look simpler. Suppose we have this function, the same function that we used in the previous example, and it just returns a promise. Okay, so how we are going to collect the data individually for three different users? So what do you think will be the result? Will the data for user 1 get printed first, then the data for user 2, and then data for user 3? Let's see. Let's save this and see. So we got the data for 3 first, then second, next, and data for ID 1 last. If we execute it again, we might get data in different order. So let's see this. Okay, execute. Oh, now we get a different order. 2, 1, 3. If we execute again, 2, 1, 3, same 1, 2, 3. This time it is 1, 2, 3. Because this is all happening asynchronously and there is no sequence here if we use promise like this. If we collect the data from promises, multiple promises like this, it is not deterministic. The output is not deterministic. We might get the data in any order. And this looks a little bit complicated. Okay, this does not look like synchronous code. So that's where async-await comes into picture. So using async-await is going to simplify our code. Let's comment this out. So now this is the function. Now let's remove this. Okay. So I can say user1 equal to this. Remember, this returns a promise. This also returns a promise. So these users are not the actual users. Rather, they are the promise. Okay. So this is first promise. This is second promise. This is third promise. Let's save and run. Okay. So if I save and run, I get three promises. They all are in the pending status. In order for us to extract the actual value, the way we are extracting the value, right? Whatever data this get user is giving, it is in this particular variable. So we can use here await. And now we cannot use await without async. So the function where we are using await needs to be marked async. So we need to put async here. Await is waiting for this promise to be resolved, then extracts the result from it and put it in this particular variable. So now user one is no longer a promise. User one is the value of that particular promise. So now it is no longer a promise, but user 2 is still a promise. User 3 is still a promise. So if I execute this, Control S, so we can see that for user 1, we got the actual data. So what does await do? Await just waits for this promise to complete. And in the while it is waiting, the main thread will not be frozen. Okay. So it will not block the main thread. So this await is going to stay there. It will wait, but it will free up the main thread to do whatever it wants to do. So let's make this also await and this make this await as well. So our code now became deterministic. it will wait for this particular code to complete without freezing the main thread. Once it gets the data for user 1, then only it will move to the next line. Once it gets the data for user 2 and stores in user 2 variable, then only it will move to the next line. So let's save this. Now you will see that the values are coming in a deterministic way. It is not random anymore. So no matter how many times we refresh this, we will get the same result in the same order. If any one of these promises throw exception, so that's where we use try catch. So we will put everything in the try catch block. So we put this in the try block, for example. Okay. And any error anywhere in these promises will be caught here. So we can say console.log. So suppose if we throw some exception here, suppose it does not, we just change this URL, for example. Okay. There is nothing like that. If we save it, what will happen? Error occurred, TypeScript failed to fetch. That's how we use async and await. So generally what I do personally, I generally use async-await a lot because it is more simpler and more readable. What will be the output of this code? You can pause the video, think about it, and then come back. So what's happening here is first work returns a promise with this particular data, first work done. Okay, it is in the resolved status. So it will go to them. But here we are not collecting that particular data. Okay, we are ignoring it. So here we are not passing any data because we are not collecting any data, we are not passing any data. So the data will become undefined, it will print to undefined, and then finally it will return a new promise with this particular data, second work done, and that's what we are returning. We are returning a new promise here that will be collected by this particular then. So whatever data this particular promise is giving, third work is going to collect it and print it here. So let's save this and see the result. So it is printing 2 undefined at line number 6, which is this line number 6, second work, because the data is undefined. And then it is printing 3, second work done at line number 11. And this is the line number 11. Let's see this with a kind of a graph, okay, how this will look like. So I have prepared this. Now let me save this. Okay, so this is how the execution will look like for this particular code. The first work will be executed. After some time, the second work will be executed, but the second work is passing undefined because there is nothing it is passing. So this second work is going to get undefined here. And then when this is done, then the third work will start like this here. Okay, I mean, we could have done something like this. Okay, like data. Okay, proper callback we could have given here. And we could have called this third work from here. Third work and passing the data. Same thing, right? Same thing. We can also give the reference of the function that we want to execute rather than the actual callback here. Okay, the same thing. What will be the output of this particular code? So again, the first work will be called, it will return the promise. Here we are not collecting the data returned by first work. So it will be undefined. And then the second work is getting called. This is the same code except we missed a return statement here. So here we are missing the return. Okay, so what will happen is because we are not returning anything, the data that will be passed to the third one will be undefined. The flow is not going to wait for second work to complete. It will immediately move to third work passing undefined because we are not returning anything. If we had returned here, okay, the actual promise, so we would get the data of this particular promise in the third work. Okay, but because we are not returning anything, there is undefined that will get passed to third work. So let's save and see the result. So here we are getting 2 undefined, 3 undefined. Let's see the flow of work. So this is how the control will flow here. So the first work will be done. It will wait for the first work to complete. It will go to second work. And because there is no return statement here, it will not wait for second work to complete. And it will immediately go to the third work, passing undefined because there is no return here. So that's how this flow will work. What will be the output of this one? Again, here we are waiting for the first work promise to be completed. And when this is done, see here what we are doing. Remember, then always needs a callback function. This is not a callback function. Okay, this is just like calling a function. If we had not put a parenthesis here, then it would work as a callback function because we are giving the reference of the function that it needs to call. But here we are not giving the reference. We are actually calling this particular function. So what will happen in this case, that whatever data that first work will return, that will directly go to the third work. Okay, so this data, it will not even wait for this particular data. Here, the first work data will directly go to the third work. okay, as the parameter. So there is a difference between this code. See here, this here we are calling the second work, but it is inside a callback function. Here we removed this callback function and directly calling this particular function. Let's save this and see the output. There you go. So it is calling the second work, okay, and whatever promise it is returning, it is ignoring it. And now the data here, see the print here. So the data for the third work is nothing but the data that is returned by the first work promise, which is the first work done. So how to fix this? How do we fix this? Just remove this particular bracket here. Now this is the call, this is the callback function. This is the pointer to a function, okay, not the actual calling the function. So let's save this and now see what will happen. This is same as writing something like this. Here we are actually collecting the data from the first work, and then we are passing this data to the second work. One last thing I would like to show you is, like, for example, there is a function and we call it, for example, get name. Okay, all it is doing is returning some name, suppose Ron. So let's see the return type of get name function. It is a string, right? But as soon as we put async here, see the return type. Now it is promise of a string. What it is doing, it is automatically converting this string into a promise. Suppose you want to return a promise, okay, from a function, just put async. I mean, you could have done the same thing by explicitly returning a promise. You could have done something like this: return new promise, and then give a callback here, okay, and say here resolve, reject, and from here and here you could have said resolve, and what you need to pass Ron here. Same thing. They both are same thing. Now this also returns a promise of a string, and this also returns a promise of a string. So you don't need to write all these lines. You just put async there. It will automatically convert this string into a promise of a string. So this is the trick you can use in your coding.